Welcome to 9.3 Angles of Depression. So we're still going to be working with our three trigonometric ratios, sine, cosine, and tangent. So what I would like you to take notice of here on the left-hand side of your piece of paper. So in our last lesson in 9.1, we talked about angles of elevation, where you're standing on the ground is the horizontal, and you're looking up at an object. Now this is a little different. So you're standing up at a high point, you're elevated somewhere. The horizontal is at your eye level, and your line of sight is looking down at whatever your object is. The angle that forms in between that horizontal and your line of sight to the object, that is the angle of depression. But if you take a look here, you're going to see that it's forming this Z-like shape. And remember, we learned in the beginning of the booklet that alternating interior angles are considered equal to each other. So this angle right here and this angle right here would actually be equal. So whatever we find out for this particular angle, then this angle would also be the same one. So we're going to keep those pieces of information in mind, so that way it will help us as we're going to solve some of our examples. Okay, we're going to take a look. So we've got our try these for this particular set. It says, name the angle of depression in the diagram. So I'm just going to blow up our diagram here just so we can see it a little bit better. And we're going to name the angle of depression. So basically we are standing right here. We're going to pretend that we're standing right here and that our eye level is this dotted line. So that's the horizontal that we're looking at, and that we're going to be looking at the line of sight is where object A is. So we want to determine what this angle is right there. So we're not sure what this angle is. So this is the angle of depression, because remember, we're standing here. This is our horizontal eye level with where we are, and this is the line of sight looking at whatever object is below us. So in between those two lines would happen to be our angle. So we don't know what it is, but we can solve it. So here we do know we've got one triangle here, and it's a right triangle, and we know that this one is 90 degrees. Because that little box tells us that that is 90 degrees. And this one already tells us that it's 72 degrees in this corner of the triangle. So if we know that this forms a right angle, then we're going to also assume, because this line is a horizontal, that this will also form a right angle. And I'm just going to put a mark there to show that it's also a right angle. And you can do that on your piece of paper too. So if we know that this is 72, how many more do we need in order to make this 90? So you can figure this out. You would take 90 degrees minus 72 degrees and equals 18 degrees. So we know that this angle that's here is worth 18 degrees. We also know that if this angle is 18 degrees, just by that Z pattern, we know that this angle here is also 18 degrees by that alternating interior angles. Alternating interior angles, just as a reminder. All right, so we are going to name this angle. So we're naming it because we're looking at this one here. So this is DCA. We're naming this angle right here. We're using the full name. We can't just use angle C because angle C is also this part here. So we have to use the full angle, the full name for DCA. C has to be in the middle part. So name the angle of depression. So DCA. And what is the angle of depression? Well, we just calculated that, and we calculated it 18 degrees. Okay, so we're going to take a look at our next little example that we got going on here. So it says a search and rescue helicopter spots a lost hiker at an angle of depression of 31 degrees. The helicopter is flying 1,100 feet directly above a ground rescue crew. How far to the nearest foot is the ground crew from the hiker? So here we have our diagram. So from the information that was given to us on the problem, it says that here's the helicopter and it spots the hiker at a depression of 31 degrees. Here's the depression here. So we're going to label that. So this is 31 degrees. And it also said that the helicopter is 1,100 feet above the ground crew. And so we're going to label that. And it says we want to know how far is the ground crew from the hiker. So we need to know what this is, and so we're going to label it X. So we're going to try and figure out some of our information here in order to solve. So remember what I said earlier about alternating interior angles? So here we're going to find that Z pattern. Oh, I'm just going to highlight it with my highlighter. Here's our alternating Z pattern. And so we know that this angle here, 31, has to equal this angle here. It's also 31 because of that alternating interior angles rule. Now, because we have this information, we can now solve to find out what X is, because we just needed two pieces of information. We've got a side and we've got an angle. So let's just label the rest of our angles to find out what type of trigonometric ratio that we're going to use. So we have our angle here, 31 degrees, and straight across from it is 1,100 feet. So this is our opposite. Here we have 31 degrees, and the side that's right beside it is the X. So this is our adjacent. So because we have opposite and adjacent, that means we're going to be using tangent. Because remember, tangent is opposite over adjacent. All right, so we're going to take a look at the problem itself and filling it in. So we already labeled the helicopter height and the angle of depression, and we labeled the distance from the crew. And we're used the given angle to calculate the measure of the other angles. Oh, we didn't do that part, so let's do that part. So we know that this one's 31 degrees. We know that's 31 degrees. We're going to figure out what this one is. So remember what I did in that last little diagram? That if this is 90 degrees, we're also going to assume that this is also 90 degrees. So I'm just going to make a little square here. And so since this is 31 degrees, how many more to make this one 90 degrees? So in order for us to figure that out, we're just going to take 90 degrees, subtract 31 degrees, and we get our answer of 59 degrees. So we know that this angle is 59 degrees. And just like that Z pattern, we got another Z pattern here going on. So if this is 59 degrees with the alternating interior angles, we also know that this is 59 degrees. All right, so now we've got everything solved, except for the X. So now we're going to solve for that. Okay. So we're using tangent of 31 degrees. So tangent of 31 degrees equals our opposite, which was 1,100 feet over the X, which we don't know what it is yet. So remember that little trick I told you, that if the unknown is on the bottom, the number that you're looking for, then all we have to do is switch places with these two. These two are going to switch places. So we're just going to skip this part here, and we're just going to switch places. So now X is over here 1100 stays where it is, but tangent of 31 moves down here now. So now using your calculator, you can determine what x is, and it's going to be in feet. So x equals whatever it is in feet. So you're going to take your calculator, 1100 divided by tan button, 31, close your bracket, hit equals, and you should be able to get your answer. If you check your calculator, your answer should be around 1,830.7 feet. So that's approximately how far the hiker is from the ground crew. And so the crew needs to go about 1,830, 31 feet is what we're going to change that to reach the hiker. So is your answer reasonable? So absolutely. If the angle of depression was smaller than the distance would increase. So I'm going to give you an example of what I mean by that. So I'm just going to grab another here. So I'm just going to draw quickly our helicopter diagram that we had. So here's our helicopter. Yeah, it's supposed to be helicopter. Here's the hiker way over here. And here's the ground crew. And we know that this is the horizontal and that this is the angle of depression. Now, if the angle of depression changed size, if it got smaller, let's say it got smaller, then that means the distance would change. The horizontal itself would remain the same, but the angle here would have gotten smaller. So then this would be, let's say this was now 20 degrees. So as you can see here, now the distance has gotten longer, has increased. And the same thing would happen if I decrease the angle of depression even more. Now we would say that this is about 15 degrees. So that means now the distance is going to be even longer. It's going to increase. If you want to draw that somewhere on your piece of paper or just trying to remember it as best as you possibly can, now you have an understanding that as angles of depression decreases, the distance will increase. All right, so we're on here. We're going to look at our first example. So here we have Luke L. is on a cliffside trail above a river. So he sees his brother Marcel M. at ground level on the far shore. The horizontal distance between them is 390 meters. So here we have Luke. Here we have Marcel. This is the cliff. And this is the distance between the two of them. Let's say if Marcel or Luke was right here, then the distance between the two of them would be 390 meters. We don't know the height of the cliff, so we're going to put that as h. It does tell us Luke is looking down at an angle of depression of 72 degrees. About how high is the cliff? So if here's the horizontal and this right here, this big space here, is the angle of depression, 72 degrees, we can use our knowledge about that Z pattern, that alternating interior angles, in order to help us do some solving on this particular diagram. So we're just going to highlight that Z pattern. And so now, knowing that Z pattern, we know that this angle and this angle in between are the same. They're equal. So this one is also 72 degrees. Okay, so now we've got some information to work with here. So we've got an angle to work with. We've got a height over here we don't know. And if we look here, here's the angle, and straight across is the height. So that is going to be our opposite. And then right beside the angle is a side that we do have information on, and that is our adjacent. We do have a hypotenuse, but the thing is there's no information here about the hypotenuse, and we don't need to use it. So we're looking for a trigonometric ratio that uses opposite and adjacent. And if we remember from our last question that we were working on, we know that tangent works with opposite over adjacent. So we're going to be figuring that out. So solution A, we already labeled all the diagram. What is the angle of elevation for Marcel? Well, if Luke's elevation angle of depression is 72, then Marcel's angle of elevation is also going to be 72. So now we can solve using the information here. We are looking at tangent of 72 degrees, opposite h over adjacent, which was 390. Now this time the unknown is not on the bottom, it's on the top. So that means that we have to get this h all by itself. So we need to do the opposite of dividing by 390. So that means we're going to multiply by 390 on both sides of the equal sign. So these two cancel each other off. We've got h by itself. And so I'm just going to rewrite this here. And now what you need to do is solve. So what's 390 times by tangent of 72? So on your calculator, you type in 390 times tan button 72, close your bracket, equals, and you'll be able to find out your answer. So if you do all that and type it all in, you should get 1200.3 meters for your height. So the cliff is about 1200 meters high, is your answer. Okay, we're going to move on to our last example here. It says a pilot begins her final descent to an airport from 300 meters above the ground. At this point, her horizontal distance to the airport is 5.7 kilometers. What is the angle of depression for her path of descent? So first of all, we've got kilometers here, and this one's in meters. So we have to change them so they're both the same. We're going to change kilometers into meters. So in order to change kilometers into meters, that means that we are going to take 5.7 and we're going to times it by 1,000, because there are 1,000 meters in 1 kilometer. So 5.7 times by 1,000 gives us 5,700 meters. So that's the number we're going to be working with. Part 2 says that we need to draw a diagram for the plane's descent. So here's our diagram. It is a right triangle, that's what we're working with. Here is our horizontal, pretty bad looking line. And here's the plane. I know it's supposed to be a plane. And here's the airport way down here. And here we have to label the angle of depression as x. So if this is the horizontal and this is the line of sight to the airport, in between here is our angle depression. And we're labeling that as x degrees. We don't know what it is yet. We do know that the height of the plane is 300 meters above ground. So that part we do know. We're going to label that. And we do know that the horizontal distance between the plane and the airport is 5,700 meters, or 5,700 meters. We do know that. So now we can figure out what we're using in order to solve. So remember, we're using that Z pattern in order to find out our alternating interior angles. So here's our Z pattern that we recognize. And so this angle and this angle are equal to each other. So that means that x degrees and this x degrees are equal. They're going to be equal. So since we just have to figure out what this angle is to know what this angle is, we're all good. So here's angle x. We need to find out what it is. We're using the 300 meters, which is directly opposite of it. So we're just going to label it opposite. We are also using the side that's right beside that angle x. So this is our adjacent. And we know from our last two questions that opposite and adjacent means that we're going to be using tangent. But this time, because we're trying to find an angle, we're going to be using inverse tan, or tan to the -1. So we're going to take our 300 meters over 5,700 meters, and we're going to divide. Now this is where you can do it one of two ways. It doesn't matter. You can divide these two right off the bat. 300 divided by 5,700 in order to find out what number you're going to be using. And remember, you can it'll be the decimal that you're going to use. So let's do it that way. So 300 divided by 5,700. So on my calculator, I get 0.0526, and I'm only doing to the 4th decimal place. So you can do it just like that. And then you would use your second function tan. So second function tan, and then type in your decimal in order to find out what the degree of the angle is going to be. So second function tan, 0.0526, close your bracket, equals, and you get an angle of 3 degrees. You can do it that way, and that's still correct. Or you can do it this way. You would put in tangent. We know we're doing second function tangent. And what you're going to do is you're just going to put in second function tan, 300 divided by 5,700, close your bracket, hit equals, and it will tell you the exact same answer. And we know that it's going to be 3. So you don't have to do the decimal and then do the second function. You can do this all in one shot. I would still mark that as still being correct, because as long as you got to the right answer, we're all good. All right. So now, the assignment part. So there's questions 1 through 6. Yes, there is, but I only want you to do number 1, number 3, and number 5. That's all I want you to do. So do number 1, 3, and 5. Make sure you show all your work. If it asks you to draw a diagram, draw one as neat as you possibly can so you understand what you're labeling. And then you should be good to go. As always, if you're stuck, please ask one of the adults in the room and we'll be around to help you. If you're at home and you're working on this and you're still not sure what to do, please, you can give me a quick text. You can give me a message on Teams or even an email, and I'll try my very best to help you as much as possible. All right, I will see you soon.